Hello students, welcome to All Force e-learning channel. This is K. Nageshwar Rao, your physics faculty. Today we are dealing with session number 38, Neet first year. Okay. In the previous sessions we have discussed about kinematic equations and their applications were discussed. Few problems were solved, graphs related physical significances were discussed, and we have made use of those physical significances to solve few problems as well, isn't it? So that's what we have completed in the previous sessions. And in this session we'll discuss about motion under gravity, and in the coming sessions, in coming few sessions also, we'll discuss about motion under gravity's applications. Okay, so what is today's topic? Motion under gravity. Motion under gravity. Motion under gravity in the sense, if a body is projected in the upward direction or if it is projected in the downward direction, if I am interested to find out how much velocity it gains after so and so time, or in how much time it reaches the ground if it is dropped from a height equal to h, or if it is projected with a velocity u in the upward direction, to what height it reaches, or after what time it reaches the highest point, or after what time it comes back to the surface again. So like that you can think about several parameters, several possible physical quantities associated with the motion of this body in the upward direction and in the downward direction. So all these kind of things will be dealt under this heading, motion under gravity. So when we start the discussion related to motion under gravity, you will be always informed about one very important key point. That key point is connected with acceleration due to gravity. What is that? Acceleration. I'll tell you what acceleration due to gravity is. See, acceleration due to what? Due to gravity. So when you project a body in the upward direction, what happens? Its velocity gradually decreases, and after reaching certain height, its velocity becomes 0, and from there it falls back again, isn't it? If you drop a body, what happens to its velocity? Its velocity gradually increases. By the time it reaches the surface, its velocity becomes maximum. So here the velocity is changing, but the change is different in upward and then in downward. In upward direction, the change is what? Decrease. The velocity decreases. That's what we call it as negative acceleration or deceleration or retardation. And all this happens because force of gravity is acting on the body. It always pulls towards the center of the earth, isn't it? So because of that reason, it when it is moving in the upward direction, its velocity gradually decreases. If you are dropping a body or if you are projecting a body in the downward direction, its velocity gradually increases because it is favored by the force of gravity, isn't it? So here two kinds of accelerations are possible. One is what? One is negative acceleration, the other one is positive acceleration. Acceleration due to gravity, it is denoted with g. Its value is also known to you. How much is that? 9.8 meter per second square, isn't it? Now, just now I told, whatever acceleration that we see in kinematic equations, that that acceleration a is replaced with what? G. If you are dealing with the upward direction motion, a will be replaced with minus g. What kind of motion? If the body is going in the upward direction, you have to replace a with minus g in the kinematic equations because its velocity decreases with the time, isn't it? If you are dealing with a situation where body is traveling in the downward direction, you have to replace a with plus g when the body is traveling in the downward direction. So these points are very important. And let me tell you a bit more about acceleration due to gravity. See, there is a chapter called Gravitation. Further, you will be you will be informed about in-depth details of acceleration due to gravity in that chapter. But right away, I am going to pick up one equation from that chapter. It's g is equal to capital G into m by r square, where capital G is called as universal gravitational constant, and this capital M is mass of the planet or mass of the earth, and this r is radius of the earth. So here, if you see this picture, whatever g is there, it is dependent on m, it is dependent on r, isn't it? Mass of the planet, it's constant. R, radius, of course, radius is not constant for earth, but let us assume that it is perfectly in spherical shape, and we'll assume that r is also constant. So whatever this g is there, it is dependent on mass of the planet and radius of the planet. isn't it? So it doesn't matter whether you project a body of huge size or small size, or a iron ball or a piece of paper. All these kinds of objects will experience the same acceleration due to gravity, which is g. If a body is projected from some other planet, their acceleration due to gravity will be different, because that planet's mass will be different, radius will be different. We have few problems where you are supposed to deal with a situation in which a body is dropped or projected on the moon. If that is the case, I want you to remember this: acceleration due to gravity on moon is equal to 1/6 of acceleration due to gravity on earth. Remember this. And let me tell you about one more point connected with this acceleration due to gravity. Acceleration due to gravity, it is purely dependent on what? Mass of the planet and radius of the planet. It doesn't depend upon mass of the body which is falling or which is projected in the upward direction. Shape, it is independent of shape of the body. It is independent of nature of the body. So whatever physical features are connected with the body which is moving in upward direction or downward direction, all those things cannot influence this small g. This small g is constant. Constant at a particular place on the planet. When you move from one place to the other place, acceleration due to gravity will vary. There are several reasons for that. I mean to say that at equator, acceleration due to gravity value will be one value. At the pole, it will be another value. It changes. It changes. Okay, it changes. Whatever details are there behind this scenario, all those things we will discuss in Gravitational chapter. For example, let me tell you about this R. Shape of the earth is something like this: oblatospheroidal. Okay, so if you see this picture, it's not perfectly a spherical object, right? So here radius at the equator, it's more when compared to polar radius. This is what, let us assume that north pole, this is south pole. So here corresponding to pole, radius is small. If radius is small, g will be large. So here g value will be more when compared to equator, when compared to g value at equator. Like that, at different positions of the earth, g value will be different. Inside the earth it will be different. Outside the earth at certain height it will be different. All these details we will discuss. But for solving problems connected with kinematic equations, you no need to have in-depth knowledge of acceleration due to gravity. All that you should know is, if you are projecting a body in the upward direction, a must be replaced with minus g. What is this a? A, uniform acceleration term that we see in kinematic equations. What are the kinematic equations? V is equal to u plus at, and s is equal to ut plus half at square, and v square minus u square is equal to 2as. Sn is equal to u plus a into n minus half. These are the kinematic equations. So if you wanted to make use of these equations to handle a situation where bodies are moving in the vertically upward direction or downward direction, you have to replace a with g. While replacing a with g, you have to mind about these sign conventions. If you are dealing with upward projected bodies, you have to replace a with minus g. If you are dealing with the bodies traveling in the downward direction, either free fall or a body projected with some initial velocity in the downward direction, you have to replace a with plus g. The reason is, when you project the body in the downward direction, its velocity increases, plus g. When you project a body in the upward direction, its velocity decreases, you have to replace with minus g. So that's how you can remember things. You can create an idea about this motion under gravity. Okay, now I'm going to replace this a. First I will consider upward projected motion. Upward projected motion in the sense you have to replace a with minus g. Let me do that. So what happens if I replace a with minus g? This equation v is equal to u plus at becomes v is equal to u minus gt, and this equation s is equal to ut. You have to replace a with minus g, then what happens? Minus half gt square and v square minus u square. Here you have to replace a with minus g, so minus 2gs, and in case of this Sn, distance traveled in nth second, u minus g of n minus half. This is in which case, if the body is projected in the upward direction. Okay. Now, what if the body is projected in the downward direction? You have to replace a with plus g. So let me modify these equations. V is equal to u plus gt. I have replaced a with plus g. Similarly, s is equal to ut plus half gt square, and third equation v square minus u square is equal to 2gs. Sn is equal to u plus g of n minus 1 by 2. So like this, equations of motion, kinematic equations of this kind gets modified like this. Okay, this is in which case if the body is traveling in the downward direction. So this is a fundamental data connected with the motion under gravity. Further, whatever situation we will be dealing with, in all those situations, these two sets of equations will be made use to handle, to solve the problem, or to apply these equations for various situations. Sometimes you will be asked a question like a body is projected in the upward direction, after what time it reaches so and so height, or after how much time it acquires so and so velocity, or velocity after so and so time, how much, or after what time it reaches maximum height. At maximum height, its velocity becomes 0, isn't it? So if a body is dropped, after what time it reaches a distance equal to so and so, or what is the time of descent, or time of fall, I mean to say time of fall. So like that, various parameters can be handled with the help of these two equations. So that's how actually we make use of these equations. Let us continue with this free fall, these equations. These equations belongs to what? If a body is traveling in the downward direction. That too, I am going to discuss with you about free fall. Remember children, free fall, or if it was said that a body is dropped, initial velocity will be what? 0. If you, in any question, if you see that a body is freely falling, in that case you have to replace u with 0. In any question, if it was said like a body is dropped from certain height, so you have to take u as 0. If a body is projected in the downward direction, like that, if it is mentioned, definitely is going to mention the velocity with which it is projected in the downward direction. Yes, you can project the body in the downward direction with some velocity. Then you have to use these equations as it is. Even in this case also, see, don't think about replacing u with 0 in this case. What is this case? If a body is projected in the upward direction, with 0 velocity, can you project any body? If you wanted to project a body in the upward direction, definitely you have to give some velocity. Some initial velocity must be given. Otherwise, you cannot project the body in the upward direction, isn't it? So here, u being 0, that kind of situation, is not possible. If you are dealing with a body projected in the upward direction, you cannot project with a initial velocity equal to 0. Okay, so now let us deal with these equations. Okay, what equations? If a body is projected with a velocity u, let us see how much height it will reach, and what is the time of ascent, in how much time it goes to the maximum possible height. We will deal about those things. Let a body is projected in the upward direction. My interest is I wanted to find out in how much time it reaches the maximum height and what that maximum height is. Okay, so let me handle this situation. What is the situation? Let us say from the ground a body is projected and it has gone to certain height. Let us say it has reached a height equal to h. So with what initial velocity it is projected? Let us say it is projected with the initial velocity equal to u. And here final velocity becomes 0. At the highest point, always final velocity becomes 0. Remember children, when the body is traveling in the upward direction, whatever acceleration in the sense here, what velocity decreases with the time, it will be in the downward direction. Acceleration due to gravity, irrespective of the direction of motion of the body, whether it is going in the upward direction or downward direction, always it acts in the downward direction. Even at the highest point where the velocity has become 0, there also acceleration due to gravity will be there and it acts in the downward direction. So this is a situation where though velocity is 0, still the body experiences acceleration, and that is acceleration due to gravity, which is directed in the downward direction, remember. So at the highest point, what happens to the velocity? Velocity becomes 0, isn't it? Since, in this case, since v is equal to what? Actually it's u plus gt. Since we are dealing with what upward motion, it becomes u minus gt, isn't it? U plus at actually. You have to replace a with minus gt, isn't it? Minus g. So now at the highest point, what is happening to velocity? Velocity becomes 0, isn't it? If velocity becomes 0, now u is equal to gt, therefore time is equal to what? U by g. So what is this? This is time of ascent. T subscript a is ascent. So time of ascent, time taken by the body to to go in the upward direction is how much? U by z. U by z. Now Let me deal with this height. What is the maximum height attained by the body if it is projected with a velocity equal to u? Of course, it was considered as h, and let us find out what that h is. H equal to what? Since v square minus u square is equal to 2g h, here you have to consider minus sign. Whatever s is there here, s is supposed to be there, right? I have replaced that s with what? H. So h is what? Total distance covered by the body in the upward direction, isn't it? So this is the maximum height attained by the body. So here finally what is happening to this velocity v? It is becoming 0. So replace with 0, what you will have? Minus gets cancelled. You will have u square equal to 2gh, and maximum height attained by the body if it is projected with a velocity u is equal to u square by 2g. So that's how you can find out maximum height attained by the body. Okay, so these are some important details connected with what? Vertically upward projected body. If a body is dropped from certain height, what happens? Let us see. If the body is dropped, what is the initial velocity? Initial velocity is 0, isn't it? If initial velocity is 0 and the body is dropped in the downward direction, what will be the first equation? V is equal to gt. Here you have to replace acceleration with what? Plus g. And the second equation is what? S is equal to ut becomes 0, so you will have half gt square. And the third one, v square minus u square is equal to what? 2g s. In fact here u won't be there because it is dropped, body is dropped. So what you are left with? V square equal to 2gs. And the last equation is what? Sn is equal to u won't be there, plus g of n minus 1 by 2. So this u becomes 0. Okay, so that's how equations gets modified. If a body is traveling in the downward direction from a height equal to h, what is the time of journey? Let us try to find out that. What is the distance traveled by the body? A distance equal to h. Let us consider this situation only. The body has gone up, and from there what? It turns back and it falls, isn't it? So when it is turning back and it's falling in the downward direction, what is the initial velocity? Initial velocity is 0. Nobody is giving some initial velocity at the highest point. It itself, whatever initial velocity is given to it initially here, with that velocity it has gone till this height, and then it is falling back. So when it is falling back, what is its initial velocity? Initial velocity is 0. If I deal with that situation, finally how much distance it has to cover? It has to cover a distance equal to again h. So I will make use of this equation. So if I replace that s with h, then what I will have? Half gt square. Therefore t square is equal to 2h by g. Therefore time of descent is equal to 2h by g, or time of fall is equal to under root 2h by g. Whatever this free fall is there, if it is seen in this situation, what is the situation? The body is projected in the upward direction. It has gone up to a certain height h, and then it is falling back. When it is falling back, what kind of motion is that? A free fall. It's like a body is dropped from a height equal to h. Such a kind of situation it is. So whatever data is present here, you can completely attribute to this situation when the body is falling back to the surface. So when the body is falling back to the surface, what is the time of descent that you have got, or time of fall? Under root 2h by g, isn't it? And we have already derived one equation for h. What is that? Here it was derived u square by 2g. So let me replace it here. If I replace it here, now what happens to this time of descent? Let us see. Time of descent is equal to under root 2 by g into h. H is what? U square by 2g, isn't it? So 2 gets cancelled, and you are left with u square by g into g square. So u square by g square under root, what you will get? U by g. So time of descent is equal to u by g. And see here, what is the time of ascent? Time of ascent is also u by g. So here time of ascent and time of descent both are same. Both are same. In whatever time it goes in the upward direction, in the same time it comes back to the surface. But remember children, this is applicable only when you ignore the air resistance. If you consider the air resistance, the situation will be different. because when the body is projected in the upward direction, air resistance opposes the motion, and force of gravity is also pulling it down. So resistance offered to the motion of the body is more, isn't it? When the body is traveling in the downward direction, air resistance acts in the upward direction and force of gravity in the downward direction, isn't it? So both the situations are different. So time of ascent and time of descent won't be equal if you take air resistance into consideration, and we'll see about that later in the later discussion. Let us continue with these equations, basic possibilities, like a freely falling case. A body is projected with the initial velocity it has reached a height equal to h. Such kind of things we'll deal, and in the later session we'll talk about air resistance also. Okay, so remember, for time being, if you ignore air resistance, if you consider that there is no any resistance offered to the motion of the body, then time of ascent and time of descent both are same, which is equal to u by g. Okay, so these are some key points connected with what vertically upward motion, vertically downward motion. Regarding vertically downward motion, the two free fall, we can have some more discussion. We'll continue with that discussion. Let me write the equations which belongs to free fall. In case of free fall, remember, a is replaced with plus g, and since it is free fall, u is equal to 0. So what are the corresponding equations? v is equal to u is 0 gt, s is equal to half gt square, and v square is equal to 2gs, Sn is equal to g of n minus half. These are the four kinematic equations in case of free fall. Okay, so we have already discussed about time of descent. Time of ascent and the time of descent both are same, which is equal to what? U by g. When a body is projected in the upward direction, it reaches certain height h and it falls back. So whatever time it takes to reach the highest position or maximum height, in the same time it reaches back to the surface of the earth. Okay, or to the point from where it is projected, it reaches in the same time. So now I'll consider this v is equal to gt. What is that v is equal to gt? This is what velocity of the object after a time equal to t. After a time equal to t. Let us say the body has reached completely to the surface. Okay, it has reached the surface. In how much time it will reach the surface? It reaches the surface in a time equal to u by g, or in terms of h also we have written time of descent. What is that? Under root 2h by g, isn't it? I'm going to replace this t with this one because I'm dealing with velocity, finally velocity acquired by the body, just before hitting the surface. Okay, so let us replace. So final velocity acquired will be g into under root 2h by g. If this g is taken into the root, what happens? G square, g gets cancelled, you will have under root 2gh. So that is the final velocity acquired by the body. The same thing can be written from here also. Just replace s with h. You will get this one. If you replace s with h, what does it mean? It means the body has completely covered the distance and it has reached the surface. Okay, so since v square is equal to 2gh, v is equal to what? Under root 2gh directly will get. Okay, so let us talk about this. So s is equal to half gt square a bit. I'm going to talk about ratio between distances covered in consecutive seconds. Consecutive seconds in the sense, I did not mean to say that in first second, in second second, in 1 second, in 2 seconds, in 3 seconds. So in 1 second, let us say the distance traveled is s1, and how much it will be? Just replace t with 1. What you will get? 1 square 1. So you will have g by 2. What about s2? S2 is distance covered in 2 seconds. Replace t with 2. What you will get? 2 square 4. So you will have S2 is equal to 4g by 2. Of course, we can simplify this further, but let us keep it like that. There is a symmetry between all the values. So these two g's gets cancelled when you talk about ratio, isn't it? So let us go with S3. S3 is what? Distance covered by the body in 3 seconds. I'm telling you, students, again, I'm not talking about a distance covered by the body in the 3rd second. I'm talking about a distance covered by the body in 3 seconds. Okay, so S3 is equal to half g into 3 square. 3 square is what? 9, isn't it? So you can write 9 here. So 9 by 2 into g. Okay, so these two things appear to be same. So 9g by 2 and so on. Okay, so let me take ratio between all these things. S1 is to S2 is to S3 is to and so on is equal to G by 2 is to 4G by 2 is to 9G by 2 is to and so on. 2 G gets cancelled. Finally, what you are left with 1 is to 4 is to 9 is to and so on. So this is what ratio between distances covered in consecutive what seconds, like in 1 second, in 2 seconds, in 3 seconds. The same thing can also be expressed as 1 square is to 2 square is to 3 square, like that also. Sometimes whenever you are asked about this kind of ratio, in the options you will see 1 is to 4 is to 9, or sometimes you also see 1 square is to 2 square is to 3 square is to and so on. Okay, if you stick to one particular pattern, sometimes without thinking, since you are familiar with this with this whatever ratio is there, okay, you will always look for this 1 is to 4 is to 9. Okay, this can also be expressed like this, and this can also be one of the options in the question. Okay, right, now let us talk about distances covered in consecutive individual seconds. I will make use of this equation. What is this Sn? Distance travelled by the body in nth second. In first second, let us say distance travelled is S1 dash, which is equal to G of n minus half. N is what? 1. 1 minus half, which is equal to 1 minus 1 by 2. So 1 by 2. So we will have G by 2. Similarly, distance covered by the body in the second S2 dash is equal to G of 2 minus 1 by 2. 2 to 0 4. 4 minus 1 3. So 3G by 2. Similarly, distance travelled by the body in third second S3 dash. Earlier, what is this? Distance covered by the body in 3 seconds. Here, distance covered by the body in the third second. So S3 dash can be written as G of n is what here? 3. So 3 minus 1 by 2, which is equal to 2 to the ratio 6. 6 minus 1 5. 5G by 2. And if you take the ratio between all these distances, what you will get? S1 dash is to S2 dash is to S3 dash is to and so on is equal to G by 2 is to 3G by 2 is to 5G by 2 is to and so on. G by 2 gets cancelled. Finally, we are left with 1 is to 3 is to 5 is to and so on. So that's how basic data connected with the kinematic equations in case of motion under gravity can be dealt. Okay, so in the next session we will continue with some other applications. Okay, thank you students.